what if I had f of x equals 3x squared cosine of x? What is the derivative? Well, this very strong inclination there is just to say, well, the derivative of 3x squared is 6x, the derivative of cosine is minus sine, 6x times minus sine. Would that be right, though? That would not be right. Because, what do I have here? We've got a product. And whenever you have a product, two things multiplied together in your function, what do you have to use? Product rule, yeah. That's an easy one, really, to forget. Yeah, use the old product rule here. The way I do it is I do the first times the derivative of the second. The derivative of cosine is minus sine. Plus then the second, which is cosine, times the derivative of the first, which is, I'm just taking 3x squared as my first, so that would be 6x derivative. You could do it other ways too, but yeah. Clean it up a little bit. 3x squared times minus 1, so that would be minus 3x squared sine of x, plus, and usually you write the trig functions last, so let's just flip those around, make it 6x cosine x. Yeah, don't forget the product rule. All right, what if we have y equals sine of x cotangent x Well, if we do treat it as a product rule, first times the derivative of the second, derivative of cotangent, remember that was, it's a co, so it's minus. Cotangent is minus cosecant squared x, plus then the second times the derivative of the first. Right. I think what one thing I was going to mention is here that does clean up a little bit, because cosecant is 1 over sine, right? So that's 1 over sine squared x. Cosecant squared would be 1 over sine squared. And so you've got a little bit of cancellation, don't you? You wind up here, this first one's minus 1 over sine of x, plus cotangent x, cosine x, which you can write that as minus the cosecant x, plus cotangent cosine. So you can look for those trig function cancellation things. All right? All right, well, here's another one. What about the derivative of y equals cotangent x minus 1 over secant x? What do I got to use there? Quotient rule, yeah. This was a little easy to remember. Obviously, we do have fraction, so quotient. Got to use a quotient rule. So I take the low, secant x, times the derivative of the high. Well, I've got cotangent minus 1, derivative of cotangent, what is that? It's a minus because it's a cotangent. We just did that one, didn't we? Cosecant squared. And then minus 1, what's the derivative of minus 1? 0. So it's just minus cosecant squared. Minus then high cotangent x minus 1 times d of the low. What's the derivative of secant? Derivative of secant is secant times the tangent. Secant x times tangent x. And then low square. Okay. So we have secant times minus cosecant squared so let's just write that minus secant times cosecant squared x. Here could multiply these things together, so I'll have minus what would that be? It would be minus cotangent x, secant x, tangent x, and then minus be plus 1, secant x, tangent x. Over secant squared. Is there anything we can clean up out of that? Well, cotangent times tangent, that's 1. Those cancel, because cotangent is 1 over tangent. So those cancel out. I've got then I've got a common factor of secant x. I could pull that out. I don't know if that'll do anything or not, but no, not really. Not a whole lot we can do with that one. I don't think. There might be others. But. Okay. They might also, too, to kind of refresh your memory, too, they might ask you to find some tangent lines with these trig functions. Might have to review bits and pieces of that. Now, all right, find the equation of the tangent line to y equals cosecant x at pi over 6, comma 2. Find the equation of the tangent line at y equals cosecant x at pi over 6, 2. Well, the name of the story is still the same. If I want to find the equation of the tangent line, what do I need to do? Find the slope of the tangent line, and the slope of the tangent line is the derivative. So what is the derivative here of my curve? So the curve's what? Cosecant x. The derivative of cosecant is minus the cosecant cotangent. At pi over 6, 2, then what's my slope? Well, it'd be, this is my x value, so it'd be minus the cosecant of pi over 6 times the cotangent of pi over 6, and that's what I was saying. You might have to review cosecant, cotangent. The way I typically think cosecant is 1 over the sine, so sine of pi over 6, let's see, sine, you got 0, pi, so sine of pi over 6 is 1/2. Just have to remember those trig identities. So the cosecant is a reciprocal of that, be 2 over 1. Cotangent, well, I remember that one is cotangent is cosine over sine. So in this case, the cosine, I've got the sine of pi over 6 is 1/2 in this case, and then cosine of pi over 6, that's square root of 3 over 2. So it's square root of 3. So the slope of the tangent line is that, minus 2 times the square root of 3. It's a nice, lovely little slope. So the equation of the tangent line would be y equals mx plus b. There's my slope, is minus 2 square root of 3. And so that's going to mean, to find the b, plug in the x and the y. 2 for y, pi over 6 for x. Yeah, it's not going to come out looking very nicely at all. I mean, you could round it off, I guess, but, well, that cancels. So 2 equals minus square root of 3 over 3 pi. Yeah, b is not a nice thing at all. Add that monster right there. That's b. So if you want exact, I'm seeing this. That's my equation of the tangent line.